Okay, now what about a system of blocks all pushed to the right with a 260 Newton force? Let's have a special condition in this case of no friction. We will now see how we can look at this as a system to find the acceleration of the blocks, the net force on each block, and the contact forces between the blocks. Let's take all three blocks and represent them as a single point of mass. We'll put that. So one more time, we see that there would be gravity going downwards and force normal upwards. Again, because we're on a horizontal surface, these two will be equal to each other. To the right, we have a force applied. And because we have a special condition of no friction, we do not have any opposing force. The force net, then, is going to equal the force applied. So what do we plug in for force net? Well, we must add all masses together. So 13 plus 14 would be 27 times A equals the 260 newtons. Acceleration, then, will be equal to 9.6 meters per second squared. Now, let's see, what about the contact forces between each of the blocks? Well, the 260 Newton force, of course, pushes on the 5 kilogram block, and the 5 kilogram block pushes right back. What would happen between the blocks, though? The 5 kilogram block, of course, will push on the 8 kilogram block, and then the 8 kilogram block will push right back. Let's call those contact forces force 1. A good example of Newton's first law, second law, and third law for this question. This being Newton's third law, for every action there's an equal and opposite reaction. The 8 kilogram block will push on the 14 kilogram block, and of course the 14 kilogram block will push right back. And we'll call that contact force 2. Now what about the value of these forces? Well, the 5 kilogram block has to push the 8 kilogram block and the 14 kilogram block at the same acceleration of 9.6 meters per second squared. So the contact force, force 1, is going to equal 8 plus 14 multiplied by the 9.6. Force 1 then has a value of 211.2 newtons. What about contact force 2? Well, force 2, again, block 8, has to push the 14 kilogram block. So then we'll say 14 times 9.6. And then force 2 is going to equal 134.4 newtons. Now again, these are equal and opposite reactions. So that means the 5 kilogram block pushes the 8 kilogram block with 211.2 newtons of force, and that comes right back at the 5 kilogram. Now what about the net forces? Well, we know net force is equal to the observed mass times acceleration, okay, for any object. So we know all of their masses and we know all of their accelerations. So the force net for the 5 kilogram block would be equal to 5 times 9.6, which equals 48 newtons. The force net, okay, for the 8 kilogram block would equal 8 times 9.6, and that equals 76.8 newtons. And finally, the force net for the 14 kilogram block would be 14 times 9.6. And that equals 134.4 newtons. We can test this to make sure it is correct by looking at the sum of the forces, maybe just on the 8 kilogram block. And we'll do that up here. The sum of the forces on the 8 kilogram block is force 1 minus force 2. Force 1 coming at it and subtracting that. So let's try that. So the force net for that block is going to equal, well, force 1 is 211.2 minus force 2 coming back at it, 134.4. And let's see what that equals. We see that the value equals 76.8 newtons, which correlates very nicely with what we calculated by Newton's second law, F equals ma.